So after a long times of made this project, we need to cut the process of bamboo because our actually project is 3 purified filtrations that we combine with a flat wall. But we have a little problem, so we need to just proceed with the flat wall deployment with hydrostatic force.
Hi, so I am here to describe our introduction. Floods are one of the most critical aspects of hydrology studies and a major concern in civil engineering. In recent years, unexpected floods have caused devastating loss of life and extensive damage to properties worldwide. To mitigate these impacts, sandbags have traditionally been used as flood barriers during heavy rainfall and monsoon seasons. However, sandbags are not durable, take time to set up, and can easily rupture, leading to pollution and inefficiency. To overcome these issues, alternative flood protection structures such as flood wall have been developed to prevent floodwater from seeping into buildings and infrastructure.
Now, let's go to the definition of terms. Hydrostatic force refers to the force exerted by a fluid on an object that is submerged or partially submerged in the fluid. It is a result of the pressure distribution within the fluid due to its weight, and the force is exerted from outside of the submerged surface of the object.
Problem statement. Sandbags remain the most commonly used flood barrier despite their many limitations. They require significant time and effort to construct, making them impractical in emergency situations. Additionally, their durability is poor, as they can break and rupture under pressure, leading to sand leakage that causes environmental pollution. The frequent need for replacement increases costs, labor demands, and logistical challenges. Furthermore, once the flood subsides, sandbags must be disposed of, creating additional waste management issues. Due to these inefficiencies, there is an urgent need for a more sustainable, cost-effective, and durable flood protection solution.
So welcome to the objective sessions. So we're gonna talk what is the aim or the objective of this project. So first of all, this project is to suggest and create simple designs of flood walls and which emphasize the concepts of hydrostatic force. Second is to construct a lab scale model that stimulates the instance flood wall systems. Third is to justify the project by experimenting and assessing the performance of the flood wall. So I think that's all for it.
First of all, we start conducting the procedure by drafting the design, sketches, and dimensions. We also decide on the size and the scale of the model. After that, we attach all of the measured prospect works together using silicon sealant according to the planned design. Next, we set up the silicon tubes at a specific position for it to function and also using silicon sealant. And finally, we tested the performance using water to see its outcome.
So how can it works? So first of all, when the water is reached to the dangerous flood level, and then it will reach the tubes, and then after that, flood water flows down the tubes, and then the water fills up the chamber under the flood wall. Look here. So it gonna like push the chamber, and the hydrostatic force is applied here. And then when the flood recedes, water will be pushed out from the tubes. After that, the water level inside the chamber under the fluid will decrease and lowers the flood wall. So that's how. Okay, so this how the flood water, like, so you can see this hydrostatic force is applied because the water push the chamber upwards and to prevent the floodwater to flow through this targeted area. So your city and your village would be in the safe conditions. So I think that's all for now. Bye.
So, we can conclude that the flood wall operated successfully and instantly with the presence of hydrostatic force exerted beneath its floor. This experiment confirmed that hydrostatic force could be a viable alternative for instantaneously operating the newly designed flood wall. Furthermore, this lab-scale extended flood wall design has proven its effectiveness as it can rise solely using floodwater. Finally, this lab-scale design demonstrated its excellent performance, exhibiting smooth and controlled rising due to the utilization of buoyancy.